Hello class, today we are going to do your Unit 8 notes on Section 2.3, Comparing Relationships. First we have some vocab words we want to make sure we understand. First of all, there is something called an x-intercept and a y-intercept. If you think of the word intercept kind of like an intersect, is this word that it's similar to? An x-intercept and a y-intercept are where your line, whenever you graph a line, it's where it crosses your x and y axis. So an x-intercept is where the line itself is crossing your x-axis. So this is your x-axis, this is your y-axis. So where it crosses the x-axis, you see it's crossing right here at this coordinate point. So the point -4, 0, that is your x-intercept. Okay, and then down here, the y-intercept is where your line crosses your y-axis. So you see that it crosses right there at this point, and that would be the point 0, 2. Okay, so x-intercept is where it crosses the x-axis, and y-intercept is where it crosses the y-axis. All right, so this point in particular, the y-intercept, is something that you're going to always see when you write an equation, when you have your equation in slope-intercept form. So when you have an example of an equation like this, say we had the equation y equals 10 plus 3x. The y-intercept is always going to be this number that doesn't have the x with it. This right here will always be my y-intercept. Okay, and sometimes we reference that number as our starting amount. Okay, so y-intercept is some sort of starting amount. And usually, especially when we're talking about word problems where we have a point where it starts at, since it's on the y-axis, and typically we're looking at just the first quadrant with word problems, that's showing that it's starting at that amount, and then it's either going up or down from that particular point. Okay, the other number, the one that's with the x, okay, this is called our rate, and it's also referenced as the coefficient of the x, and you'll see that word coefficient shows up right here in your definition. So the coefficient is the number multiplied by the variable in the equation. So in this case, it's the 3. So that's the coefficient of the x, which is our rate in many or in our equations. Okay. All right. Now, when you graph a line, there is also many solutions to the equation. So these coordinate points, the point -4, 0, and this point 0, 2, those are just two examples of solutions on that line. There are many solutions, though. Any point within that line would be a solution to the equation. So it's an ordered pair that makes the equation true and lies on the graph of the line. Okay, so we have some examples back here that reference back to our Henry and Emil when they had their walking rates. This one going up at 2.5 every second, and this one going up, having that starting rate of 45 and then going up by 1s. But any point within that line, or any point data point that you collect, will end up being on that line as well. Okay, so let's go ahead and turn the page. Now we're going to look specifically at a situation and talk about how it interrelates to this stuff. Okay, so first we have Ms. Chang's class decides to give t-shirts to each person who participates in the walkathon. They they receive bids for the cost of the t-shirts from two different companies. Mighty Tees charges $49 plus $1 per t-shirt, and No Shrink Tees charges just $4.50 per t-shirt. Mrs. Chang writes the following equations to represent the relationship between the cost to the number of t-shirts. So you'll see this is for the C stands for cost, so the cost for the Mighty Tees, there's that $49, that's what we can reference as our starting amount, and it's plus, see the plus, $1 per t-shirt. So if N is my t-shirts, if I had 1 times N, that would just be N, so I don't have to put the 1 in there. Okay, and then the other one, No Shrink Tees, is $4.50 per t-shirt, so $4.50 times the number of shirts, that will give you the cost. All right, so we're going to go through and we're going to answer all these questions that are right here, but they're actually right here in our chart. But first we have to decide, if we were to graph this, What is my independent and dependent variable? So we have two things up here. We have cost, and then our number of t-shirts. So C is cost and N is the number of t-shirts. So we have to ask ourselves, which one depends on the other? Does the number of t-shirts depend on the cost, or does the cost depend on the t-shirts? Well, how much it costs